Hello, good evening to all of you. I hope all of you are doing well. So, in today's class, we are going to learn about return by reference. So, a function may also return a reference. As in the previous class, we have learned about different ways of calling a function that is called by value and called by reference. So, here now, what we have is we have a function that's capable of returning a reference. So, a function may also return a reference. So, let us try to understand it with the help of an example. So here I've written a very simple program that is capable of determining maximum of two numbers. Now to see here what I've done is I've declared a variable, I've declared a function, sorry, max. So max is a function that takes in references to two integer values. You see, the first reference and the second reference, right? So it's capable of taking in reference to two integer values and it's capable of returning a reference to integer value. So it takes in two reference variables and it returns one reference variable. Now here, just see I have defined my main function. I've defined my main function. So main is defined as, just see here. So what I have is I have two variables, val a and val b, being declared as integer. Then what I've done is I've read the values into val a and val b. I've read the values into val a and val b, and then I have called the function max. Okay, I've called the function max. Just see what I have passed to the function max is I passed val a and I passed val b. Now here, when this function max is being called, now val a is being referred to by val x. Now just see val x is a reference variable. So you must remember we have discussed reference variable in the previous class. So val x is a reference to val a, whereas val y is a reference to val b. Okay, so val x is reference to val a and val y is reference to val b. That basically means now val x and val y are alternative names or allies to val a and val b. So this is what we have learned in the previous class about reference variable. So now here what I can do is I can use val x and val y as an alternative name for val a and val b. So now here what I've done is I have determined greatest amongst two by implementing. So if val x is greater than val y, then return val x, or else return val y. Now just see here what we are doing is we are returning reference variable again. So now that reference, just see the return type of max is reference variable. So that reference variable that is being returned by max is getting initialized to p max. Now just see p max again is a reference variable. So here p max will be either referring to val a or val b through val x and val y. Now val x and val y are reference to val a and val b. Likewise, I am returning either val x or val y. So pmx will be referring to either val x or val y, which will be further creating a reference to val a or val b. So here now I'm printing the value of maximum, that is pmax, which will be either val x or val y, where val x and val y are reference to val a and val b. So this is the way how what we can do is we can return reference variable or return reference. Okay, now the next important concept in case of C++ is called as inline function. Now whenever just see, listen to me carefully. Whenever a function gets executed, right? Now let us identify the sequence of steps. What happens when a function gets executed? So whenever a function calls another function, the sequence of execution goes in this particular manner. So let us consider there is a function a that is calling a function b, right? Okay, so whenever a calls b, now what I need to do is before function call is linked to the function definition, I need to store the return address in a before the transfer of control takes place to b, because I need to know after executing b where I need to come back to. Now this particular process is called as storing of the address into the stack, right? Okay, so now whenever a function call is made, first the return address is stored onto the stack. Okay, the place where I need to come back, the return address is stored onto the stack. The transfer of control takes place, that is called as linking. The function execution takes place, and again what I need to do is I need to return back after executing the called function to the calling function, right, by remembering the address where I need to come back. So the address is stored onto the stack. So what I'll do is I'll take out that address, and again I'll resume the execution of the program. Now you see, this is the sequence of execution. So when a function is being called, you need to store the address, you need to transfer control, execute the function, return back to the address that is stored onto the stack. Now, what is this stack? So this stack is a dynamically implemented data structure for every program. So whenever a program gets executed, there is automatically a dynamic stack that is being created that's called as call stack, that's capable of storing the return address. Okay, right? So for every program, you have a stack being created. So that is the sequence of execution that takes place. So let us go through it in detail now. So whenever the program executes the function call instruction, the CPU stores the memory address of the instruction following the call instruction and copies the argument of the function onto the stack. So what we need to do is we need to store the address of the address where I need to come back to onto the stack. And finally, the control of transfer takes place. So before the control of transfer takes place, before the function call is linked to the function definition, I need to store the return address onto the stack. Now, after then, so once the transfer takes place, the CPU executes the function code, stores the return values into the register, and returns the call control to the calling function, because I need to ensure that the program is completely executed. So for that, what I need to do is I need to return back to the calling function. I need to return back to the calling function, and I need to resume the execution of the program. Now, how it is done? It is done basically by popping out the content of the stack. If I pop out the content of the stack, I'll be popping out the return address. So then I'll resume the execution of the program. Now, in certain situation, it may so happen, right? In certain situation, it may so happen that the function execution time may be far less than that of the linking time and the return time required. Okay, so because I need to link the function call to the function definition, I need to execute the function, and I need to return back. Now it may so happen that switching time may be far more than that of the function execution time. So in such kind of situation, there is an overhead. There is an additional burden that the execution time has to bear because of the linking time and the return time. So in order to prevent that, what we can do is we can use the concept of inline function. Okay, and so we can use the concept of inline function in situation when there is overhead because of the linking time and the return time. Okay, so C++ provides the concept of inline function, where what happens is that whenever a function that is declared as inline is invoked, okay, whenever a function that is declared as inline is invoked, what happens? The function call is replaced by the function definition, not at execution time but at compile time. So what happens is that the entire function, the entire code replaces the function call in case of inline function, right, during compile time. So now just see, in such a case where the function call is being replaced by the function definition at runtime, so at execution time I need not link. If I need not link, I need not return back. So there is no switching time that is required, or we are completely eradicating the switching time. So this is the concept of inline function. So if a function is declared as inline, the compiler, just see, if a function is declared as inline, the compiler places a copy of the code of the function at each point when the function is called at compile time. So this replacement of the code, replacement of the call by the code takes place at compile time, so that during execution time you need not link and you need not return back. So you can completely avoid that switching time. But what you need to always ensure is that whenever any change is brought about in the inline function, then what we need to do is we need to recompile it, because we need to replace the new definition or the old definition by the new definition of the inline function, right? So here, how we can make a function inline function by simply placing the keyword inline before the function name and define the function. Okay, right? Now just see here, what I have is I have a function. So this is a normal function definition. Just see, this is a normal function definition. So here, what I've done is I have placed an inline keyword before that. This makes the function inline. Okay, but now there are certain limitations of inline function. The first limitation is that a function cannot be inline if a function has a loop. Okay, right? A function cannot be inline function if it contains a loop. First thing is that. The second thing is a function. If a function contains static variables, we cannot make a function inline. Okay. If a function is recursive in nature, we cannot make it inline. Okay. Right. If a function returns anything other than void and the return type is not specified in the function body, we cannot make it inline. Okay. If a function contains switch or go to statement, we cannot make it inline. So these are the criterias. If satisfied, what we cannot do is we cannot make a function inline. Now there are several advantages of inline function. The first advantage, as we have already said, so here if you make a function inline, then what we can do is we can completely avoid the switching time. So we can completely avoid the overhead, right? Again, and if the switching time is not there, so if a function call is not linked to the function definition, then there is no question of pushing or popping the address onto the stack. So that is also avoided, right? So time required to push and pop variables into the stack is also avoided. In case here, if there is no linking, then there won't be any return. So that return time is also avoided. So this I have explicitly placed it here, right? The next advantage is that it may enable the compiler to perform context-specific optimization of the body of the function. Definitely. So here, what we're not allowed to do is we're not allowed to use complex constructs in case of inline function. Definitely, code optimization will be there. So these are some of the notable advantages of inline function. Now there are a set of disadvantages as well of inline function. So we'll go through some of the disadvantages. So if we make a function inline and substitute the function call by the function definition, then the total number of function variables that are getting inserted into the program will also increase. So this is one of the biggest problem with inline function. So as and when the function call is being replaced by function definition, then there definitely there will be increase in the number of variables. The second important disadvantage is that when there are too many number of inline replacements of the function call by the function definition, then definitely the size of the program will increase, which may not be actually accepted, because in case of situations where you have limited space to work with, inline function may not come in handy, because each whenever inline function is called, the function call is replaced by function definition. So every function call is replaced by a set of lines of code, right, which may definitely increase the size of the program. So this is also one of the biggest disadvantages of using inline function. Another disadvantage of using inline function is that use of inline function may increase the compile time, because here what happens is that inlining takes place during compile time. So every function call has to be replaced by function definition at compile time, and moreover, if any change is brought about to the inline function, then the entire program has to be recompiled again, right? The entire function has to be entire program has to be recompiled again, because the old definition has to be replaced by the new definition. So this is one of the major lags of the inline function. So, and then inline function may not be useful for many embedded systems, as I've already said. In situation where the memory, you have limited amount of memory cells for storing the program and data, and use of inline function definitely increases the size of the program. So definitely in situation where you have a restriction on the number of bytes of memory to use for the program, inline function may not come in handy. So these are the few of the disadvantages that inline function has, right? Inline function has. So based on the circumstances that you have, if you can compromise on the memory space for saving time, then what you can do is you can use inline function. So here, what I've done is I have written a program that uh, uh, exhibits the property of inline function. So now just see here what I have is I have a class. I have a class operation. I have a class operation where I have the variables being declared a, b, add, sum, and multiply. So it's a function that's capable of finding. It's a program that's capable of realizing a digital calculator in very simple terms. So I have input variables a and b, and I have the variables add, sum, multiply, and divide capable of storing the result. So here these are the private members of the class operation. So I have the behavior is being placed in the public domain. Okay, so now what I have done is I have made all the functions inline. Just see the get function inline, the sum function inline. Okay, so all the operations are being placed as inline. So here I'm defining the function get outside the class. So here what I'll do is I'll use the necessary syntax. We have already been through this. So get function reads the value of a and b from the input stream, right? Again, and then we have a sum being defined as an inline function where it adds up the value and returns the displays the sum here, right? So again here operation difference. So difference is a function again that's defined as inline, okay, belonging to class operation. So it finds the difference of two variables and it displays the results. So likewise product, it displays the result, and division, it displays the result. So here just see what I've done is I've just written program using inline function. So I've declared an object of type operation s. So I've invoked each of the function using that particular object s. Now each of the invocation to the function will be replaced by its definition. So here s dot get will be replaced by the definition of the function get, because since it's an inline function, so here it will be replaced by this sequence of instruction. Likewise add will be replaced by this sequence of instruction. Okay, likewise the difference will be replaced with this set of instruction, and multiply will be replaced with this set of instruction. Likewise divide will be replaced by these two set of, right? Okay, now just see that's what happens. So whenever a function is implemented as an inline function, then the function call is replaced by the function definition. So this is what we have learned. So in today's class what we have learned about is we have learned about returning by reference. Okay, so what we can do is we can return by reference. Okay, we can return a reference from a calling function, from a function being called. So here what we've done is we have taken a very simple example of determining maximum of two numbers, where what we are doing is we are taking in two reference variables and we are returning a reference variable again, right? So here using reference variable, what we are trying to do is we are trying to create a reference to the actual parameters val and val p, and eventually Pmax is referring to either of val A and val B, right? So reference variables are not nothing but allies, as we have already learned in the previous class. And then we have discussed inline function. We have learned about what are the inherent overheads that are involved in function call. So yeah, whenever a function call is being made, the address is to be stored, the linking is to be done, the function execution is to be done, and the return is to be done. So this overhead can be avoided with the help of inline function. But we have learned that the inline function has certain set of certain circumstances under which they do not work. So we have learned that inline function does not work whenever there is a loop, whenever there is a static variable, whenever there is a recursive call, whenever the return type is not void but the function does not return any value, or when the function contains switch or go to. So we have learned about some of the advantages of our inline function, and we have been through some of the disadvantages of inline function as well. Okay, and then we discussed a very simple program that explains the way how inlining works. So here we have implemented a simple digital calculator that finds the sum, difference, product, and the result of division operation, where each and every function are implemented as an inline function. So we've learned about that. Whenever a function call is made, the function call is replaced with the function definition. So this is all we're going to discuss for this particular class. Thank you very much.